what we're going to do first and foremost is invite my panelists. So I have Guy Gerritz, like ferrets. Sorry, I had to say it, 'cause that's how I pronounce his name. And Guy is the Director of Energy and Infrastructures for EMEA at Nvidia. And next we have Ryan Carver. Dun, 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 dun. Ryan is the Senior Director of DC Infrastructure, Innovation, and Sustainability at Microsoft. And finally, we have Shores van der Wright, I got it right, woo, who is the General Manager of Tech Sector, Renewables and Energy Solutions at Shell. Everybody's got really long titles. It's quite a mouthful. Well, good morning, everybody, and welcome to our session on the next frontier of sustainability of data centers. And good morning to my panelists. Everybody, thank you very much for being here. And all of them have traveled quite long distances recently and been quite busy. But we're going to jump in because we have a lot to discuss. And, well, we all know what's going on, but we don't really know what's going on. One thing I do want to start out by saying, and we'll probably talk about that a little bit, is the partnerships in this sector are incredible right now. The fact that we have three major companies that are all working together on something that is very important for everybody in the future is remarkable. And I just want to say that up front. So please give all of them a round of applause for being collaborative, as we know it's always sometimes lacking in the tech sector. So, but let's jump in. And I'm just going to say, first of all, and I've got all my questions written down because we have a lot of stuff to get through. So I am going to go to Ryan because we know that there is that current status, and we want to know what the key challenges are that data centers are really facing in terms of sustainability and operations. What's going on?
Well, when it comes to sustainability and operations, our three major challenges would be our energy consumption, making sure that we're consuming renewable energy, number one, with as little or zero embodied carbon as possible, which is really kind of ties into our 100-100-0 goal from Microsoft, where we have a global commitment to consume 100% renewable energy 100% of the time, 24/7. That's going to be our first challenge. Our second challenge would be our water consumption. And right now we're actively pursuing different ways to reduce our water consumption through different kinds of media filtration, recycling water, making sure that we're not consuming potable water. And the third would be how we manage our e-waste. So we have a tremendous amount of e-waste that is produced from our IT equipment and hardware at the scale that we operate at, along with the other hyperscale cloud providers. And what we're doing to manage our e-waste is we are developing what we're calling circular centers on our data center campuses. So we're developing circular centers on our data center campuses in order to recycle, refurbish, and reuse our IT equipment or donate it to local communities. And this is reducing our e-waste by over 80%. And as you can imagine, we've got hundreds of metric tons of e-waste per year. So reducing by over 80% in many conditions is very, very significant. So those are the three main challenges that we're dealing with today.
Okay, and I didn't do that thing where I asked you all to introduce yourselves and give a little bit of your background, but I'd like you to just say, first of all, how that ties into what you do.
Okay, so kind of going back.
Yeah,
So,
since I just jumped ahead, didn't I? Jumped right to the discussion.
That's okay. So again, Ryan Carver. I've got the pleasure and the privilege of leading our innovation, sustainability, and optimization execution teams on the data center side of the house, working for cloud operations and innovation. And what my team does is a couple of different things. So first of all, we work with multiple different brilliant teams across Microsoft that perform data center advanced development with one of my peers, Christian Bellotti. Work with our energy team, General Manager Brian Janis, as well as our partners in the software side of the house, from Azure Office, Xbox, Bing, so on and so forth. And what we do is we work collaboratively to test out new innovations, prototype them in live environments after the research has been done. And then we take the data after prototyping, put it back into the system, and if the data proves out it's going to be something that's good for Microsoft and the world, then we will build that technology into our portfolio. If it's technology that's new and immature, what we will do is work to develop the supply chain or to mature that technology. And then I've also got an optimization team that looks at how we can optimize all of our existing assets as intelligently as possible. Just because we're a giant transnational corporation doesn't mean we need to operate in any way wastefully at all. So again, we look to optimize all of our existing assets, consume less green space, look at how we can better utilize our existing spaces and things of that nature. So a little bit about me.
I gave you an extra 15 seconds. All right, so everybody keep in mind what was said about his response with question number 1, because I'm going to have these two gentlemen introduce themselves first, because I did jump ahead. I was like, get into the discussion. So, Guy, would you like to introduce yourself, tell us a little bit about yourself? 1 minute.
Okay, all right.
I won't take away from you because, you know, Ryan took that extra 15 seconds.
Okay.
So give us a 1 minute overview of what you do at Nvidia.
Okay. I worked at Nvidia for the last 10 years. That has been all within the energy industry. And to be brutally honest, that has meant, until fairly recently, the upstream oil and gas industry on the geoscience side. So seismic imaging, reservoir simulation, all kinds of interactive graphics to do with interpretation of the subsurface. About 3 years ago, there was this cloud on the horizon. Well, there were two clouds. There was the advent of AI, maybe a little bit earlier than that, but there was another cloud on the horizon, which was the energy transition. That has really accelerated for two reasons. One was a crisis within the oil industry itself, and then it was followed by the pandemic. And that has changed a lot of how we're even working, how we're traveling, what we're doing. And it's broadened out the whole question of the energy industry, what it does, and how that ties in with AI and IT. So from Nvidia point of view, AI was something that we were really involved with at an early stage, about 10 years ago, but it was fairly hush-hush until about 2015 or so. And then it's broadened hugely because of, you know, the big hyperscalers like Microsoft providing the means to actually access technology to develop all these AI use cases. So from our point of view, what we're trying to do is three things. We're trying to accelerate all kinds of applications and use cases with the GPU platform. We're trying to help facilitate access to those resources wherever you are, remotely, through VDI, through virtualization. And the third is, how do we build this whole AI use case, value propositions and ecosystem to bring this forward, particularly in the energy industry, which is, for me, a fundamental one. It underpins a national, international infrastructures, and it also underpins all industries. So that's kind of where we are at Nvidia.
Do you like how he tied in the response to question number 1 within that? That was nice. I like that. Thank you very much, Guy. Shores, like as in seashore.
Should I try and do the same and tie in my...
If you want to.
I will.
Yes, of course.
I will. Thank you. So, Jos van der Rijt, I'm what we call the GM for the tech sector in Shell. Basically, some of you heard Daniel speak about how Shell looks at decarbonization of different sectors, and we've really sort of aligned ourselves around what are the problems of individual industries in terms of how can they become more sustainable, use energy more efficiently, use less energy, and sort of be on you know, in line with the goals of Paris. So my role and my team's role is specifically to look at different companies in this sector, part of which we're discussing today, here, right, data centers. So that's what I'm responsible for, and includes partnerships, again, with, you know, such as Microsoft and Nvidia. How do we work together on the problems of this industry as a role of an energy provider, but also really being a thought partner and a partner on the journey of decarbonization. Now, what makes this particular sector so interesting is that, of course, it's a two-way street. It's almost a three-way street. There's an element of what can we as an energy provider do to help this sector, but really this sector is also helping us through AI, through having a more efficient cloud. They're also helping us as an energy sector decarbonize, as Guy was already referring to. And then thirdly, and not necessarily unimportant either, is how do we work together to decarbonize other industries or the energy system, right? Because, and Suki, you notice, and a lot of you will notice, the energy system itself is really changing as well, right? It's no longer one central, power plant pushing power down, and everybody uses it. That whole system of power is changing, and power is only part of the energy system, right? That's the other thing to keep in mind. So there's a lot of really interesting challenges. If I look particularly, and if you'll allow me to build a little bit on Ryan's points earlier.
Yes.
I think, yes, you said it, Ryan, really well, like, efficiency, the usage of energy. But there's two different points to that, right? There's the PUE type, how far can we drive that down? And that really works if you're using carbon intensive energy. If you're already 100% green, which is a rare case, right? But still, then there's still a point in doing it, but it comes from a cost perspective and other perspectives, right? So that's definitely, I think those two are related but separate. From my perspective, it's really important to work on both, as you were saying, to get to that 100, 0. Then there's the footprint of data centers, right? And it's the footprint of how big are they, so how can you make them potentially smaller and more efficient and effective? And then the footprint of where are they and how much is this growing? Because we are doing more compute, not just because we take bigger pictures and make more movies, but because of AI. So also the need for data center growth will continue, and hence the challenge we have now will just grow in a way. So it's it's really interesting. We're coming as a current.
Thank you, and thank you for building on that. So now we can just hop to the next question. So one of the things that really is quite big is the role of innovation. And I know that this is an area that you are very much into, Guy. So I'd love to know, how do you see innovation play and in what role in the efficiency, especially of data centers?
Well, I think the fundamental one from our point of view is getting things done faster. If you can do something 5 times faster with the same amount of energy, then that's basically energy efficient. And that's really what we've been doing every 2 years, is to introduce a new architecture that can deliver 40 to 100% more performance than the previous one. So that is implicit energy efficiency to us. The rest of it has to do with data center design. We work with our partners, whether these are OEMs, companies like Microsoft, hyperscalers, in order to do that, and also our customers that have data centers of their own. One of the things for sure, the scalability required for the future, the near future, is far greater than what we think about even today, or we used to think about. We used to think that 3 megawatts or 4 megawatts was a lot. Now they're talking about 10, 20, more than that. To deliver that kind of scalability will require a lot of innovation, both in terms of how the thing operates, within the systems themselves, how to create the most efficient movement of data and applications within the system, but also how to have a power supply and heat management that will allow that data center to function at scale. And some of that involves immersion cooling. Some of that really depends on where these data centers are. You can take advantage of certain geographic features like northern Norway is conveniently cold. That's a good way to cool systems sometimes. There are other ways, but I think a lot of things that have to do with optimization. There are other things which will have to be transformational to deliver the kind of data centers of the future, which will be able to run the AI use cases that we have in mind, because AI is not a light use case. computationally it needs a lot of power. That will be expected, and it will have to be done efficiently and within certain cost constraints. So innovation is really the key thing here. And I'll be honest, we are aligning with the energy industry. We don't know the answers necessarily. I don't think anybody does. But this is the point of the partnership. We're going to go along this journey with our respective areas of competence, and hopefully some of the things which are really big challenges will be solved over the time span we're talking about to 2050.
Definitely. And as you were mentioning about immersion cooling, I know that Ryan, you have very much to add on the Microsoft stance on that. So if you would please expand for the audience.
Yeah, absolutely. And I'll try to reduce it since I took that extra 15 seconds in the beginning.
You're good, you're good.
Sorry about that. So to build on your innovation response before I get into the immersion cooling, if you don't mind, just very briefly, innovation is absolutely critical for success. And it's not only critical for success, but if you do not continue to innovate and look forward, you will cease to exist. If you do not evolve, you're not looking forward continuously. And now with some of the, not some of it, but there's a massive sustainability push, more in certain parts of the world than others, such as certain parts of Western Europe, United States, and other countries around the globe. There's starting to become sort of an inextricable linkage between sustainability and innovation as they operate together collectively. And that's something that we're beginning to see with immersion cooling. And you just asked about immersion cooling, Suki, and I'll jump into that briefly. Right now we're experimenting with multiple different types of immersion cooling, multiple different types of fluid, single-phase fluids, two-phase fluids, cold plate, which isn't exactly immersion, but cold plate cooling. And we're looking at the different types of cooling, how the fluids respond, what the thermal exchange looks like, how much enhanced computing performance that you get at the chip, which you just mentioned also. Okay. Some of the density and sustainability benefits that come with that. The reduced embodied carbon because of your density opportunities that you've got when it comes to immersion cooling. So yeah, right now we're looking at single phase, two phase, cold plate cooling, looking at how different workloads respond in each of those fluids, evaluating the data that's being produced out of that, and making determinations as to how we're going to continue to move forward in that space. So.
Impressive. Shores, do you have anything you'd like to add?
Yeah, absolutely. Thank you. I think, as we said before, we all have a role to play in this ecosystem, right? You talked about the partnerships, and I think in our partnerships, it is so incredibly important to continue to work closely together to accelerate that innovation. So to Guy's point of it, acceleration leading to efficiency, and this is where, as Shell, we're the number one lubricants provider in the world, right? We're very good at liquids and coolants. And you know what? This is also something that you can roll out quickly. I mean, you can talk about hydrogen and CCS and direct air capture, which are all super important and part of the future. And we talk about those things as well, right? Between ourselves.
Absolutely.
But it's also important to think about what can we do today and tomorrow in order to get on that journey and accelerate it. And immersion cooling is definitely one of those things. We're very excited about it. A lot of people in the industry are very excited about it. But as Ryan is saying, you gotta test. You gotta make sure it works, right? Because ultimately, for a data center, and we run data centers, right? We have our own high-performance compute data centers, which need a lot of cooling, because those GPUs, Guy's gonna correct me here, run up to like 38 kilowatts and higher or something, at which point air cooling isn't even enough, right? So close enough. All right. So we all have a role to play, but we can play that role better if we work together on these things. And immersion cooling is one example. AI is another one. Again, as I said earlier on in the introduction, AI and cloud and the development of both those things, by companies like Nvidia and Microsoft, have also really helped Shell to become more efficient in the parts of our business that are the more traditional parts of our business. All the sensors that we have on all of the equipment allow us to operate more efficiently, and more sustainably ultimately, as well. So, yeah, that'd be my bill.
And actually just taking up your point on AI, because there is really the big AI component. I mean, we're at CogX, really in enhancing the cleaning function of data centers. I've got this long question here. I apologize. It's like, can you share your view on how AI is contributing to the energy transition and the role of GPU, accelerated computing platforms, in driving HPC and AI use cases to achieve a higher and a greater scalability and performance in data centers? I mean, basically at lower levels of footprint, cost, and power consumption, because we know that they are somewhat. So that was a long question. I'm going to go,
Okay.
Guy's like, yeah. I fell asleep during that. All right, Guy, I'm going to go to you first.
As far as the energy transition is concerned, well, you probably know the energy mix already. It's like 80% fossil fuels still. In the UK, I think it's only 10% is renewables. So that's the situation today, and that has to change. Within the oil industry, they themselves know that carbon capture and sequestration is going to be very important to the future of the industry. So they're gearing up for that, and they're using high-performance computing techniques previously used for the subsurface to find and extract oil and gas, to actually put CO2 back into formations that can contain the CO2 and won't leak. And to do that, they'll have to use the same monitoring, modeling techniques as they do today for exploration and production. The other areas which are also extremely important is how do you combine dispersed teams without them traveling and moving around, burning carbon fuels? How do you manage and monitor and create digital twins out of the assets to make them more efficient and more energy efficient? And then the other things are to do with how on earth are you going to manage an entire energy system which combines different sources, different fluctuations in source. How do you kick in something that's seamless so that you assure continuity of supply across one particular region, but how do you then share energy across entire regions such as Europe, Middle East and Africa, where you have huge disparities between what kind of energy is available. Some people have surpluses, maybe for a day or two, that they can share with other countries. So there's a trading and sharing function that has to be built, and all of this would have to be automated. It's far too complex to have people, pulling levers and shouting into telephones. It will have to be done to a large extent in an automated fashion. And this is all areas of AI that we foresee being necessary to create the energy transition. So sorry.
Brian's like, and I want to say something now.
No.
Oh, no, go ahead.
When it comes to AI and energy transformation, just to kind of build on what you were saying, Guy, when you look at how the data centers operate, even bigger than the data center, if you look at, I'm going to kind of build off of what you said earlier around PPAs and then what you're talking about when it comes to AI. I don't want to discredit PPAs at all. But what Microsoft is focusing on is really the rapid decarbonization of the entire grid. Yep. And how we're doing that right now is through the purchase of renewable energy from wind and solar, and really demonstrating that we can alter and diversify the energy sources on the grid to push more renewable energy sources onto the grid. And our largest tool to do that, again, is through renewable PPAs. But the larger question is, how do we do that from a larger system-wide approach, which is really going to be the challenge over the next 10 years. How do we develop, monitor, manage, and maintain a resilient grid in a responsible way? And one of the tools that at least I see, or one of the only ways we're going to be able to do that, is going to be through utilization of AI. So that's it for me.
Yeah.
You wanted to add something?
Yeah, no, absolutely. I mean, I think Ryan's absolutely right. the system is the important element, because ultimately we can get one data center to 100, 0. But then ultimately, what have we done for the entire system, right? There's no point in us, for lack of a better word, sucking energy away from other sources that need it to optimize one asset. We're going to have to solve this problem at a macro level, and AI plays a massive role in this. I also want to mention the cloud, because the cloud also plays an enormous role in us, as a society, be able to leverage all of that AI. And again, without the energy, so now I'm kind of going chair by chair almost, you don't get there either. You're going to need to be trading, in real time. And all of this sounds easy, right? It sounds easy to say, oh, I put a charge post at my house, and then, that one will feed back to the grid and will feed into my battery, and, at night, all of this. That doesn't just happen, right? You need the hardware, you need the software, you need the energy, and you need all of it to come together. And none of that's going to happen with AI, which then brings us back to our earlier point, or without AI, which brings us back to our earlier point, which is there's going to be more and more of this. Yeah. So the challenge of data center decarbonization isn't going to go away. It's just going to get bigger. That's what we're here to work on.
So we're actually running on good time here. So I have one more question, but I'm going to throw another one into the mix because I'm like that. Because we were having a conversation earlier, Guy and I, about just infrastructure. And one of the biggest, and this is something we haven't discussed, so I'm just going to put you all on the spot. With infrastructure, one of the things that I have been seeing recently and following is the fact that there are people writing papers about mega cities and mega projects, but the role of data centers in that, I mean, is anybody working with those groups on mega cities? Because that needs to happen. Those cities are going to probably, hopefully, be scalable, sustainable, 100% environmentally friendly. If you're going to build a new city, it should be that way. If you're going to build on a city, it should be that way. So I was wondering if there are any partnerships, any discussions, any work in that area. And I just put them all on the spot because they didn't know I was going to ask that. So.
I can just take a quick stab at that. So when it comes to like partnerships with new cities that are going to be developed, I can't really speak specifically to that at the moment. What I can say is that we are working towards a future where we're going to have data centers that are developed out of completely regenerous materials. And the heat that's rejected from the data centers we're going to be using, or goal is to use them to heat, say, like greenhouses, or plug into district heating loops in parts of the country that are in need of heat to keep the streets and the roads and the sidewalks de-iced, such as locations like Sweden, Finland, things of that nature. But when it comes to like future infrastructure, we have been looking at regenerous data centers. It's something that is a long-term goal, but we're actively working on that right now, actually.
I just think that's really interesting also.
Maybe quick build on that. So yeah, partnerships with cities, absolutely, right? Cities is super important, and it's something that we look at, and also, I'll take the example of the city of Houston, where I live. We're looking together with Microsoft and other partners as well as what can we do to decarbonize Houston. A lot of work to do. So definitely specific focus on that, and some of that's also transferable to other cities, of course, some of those learnings. I think the other thing that we maybe touch on with the heat recovery, for instance, is, and we haven't really talked about it, is the move of data centers to the edge and compute to the edge, right? In which case you get perhaps smaller or more local, or maybe even data centers in buildings in some cases where you can reuse that heat more easily. Because some of the challenge, if you have a big box data center outside in the countryside, is to say, okay, we could theoretically reuse all that heat, and if we use immersion cooling, even more, because the heat recovery gets so much better. But then where are we going to go? Because we're really far away from anybody that could use, 55 degrees Celsius heat or something. Whereas if you go more to the edge and you're more in those buildings, then that starts to become easier. So yeah, absolutely agree. Heat recovery is something that's really important for cities. And we are working, I think, in the city of Amsterdam on some of that as well.
Yeah, I'd say that's probably one of the biggest problems is the density of large cities and where you don't have a lot of space. That's the human population of the world. I'd say we're probably the biggest issue.
That's actually a really important point that you
Yes.
bring up there when it comes to density, Suki. One of the major benefits of immersion cooling that we're looking for is the density improvement. When you can improve the density of your data center by, say, up to 2/3, you're reducing your footprint by up to 2/3.
Yeah.
Then you can, I mean, obviously you're going to take up less green space. You can develop more edge computing, edge sites in denser cities where real estate is at a premium. You've got enhanced energy utilization, you've got a better PUE, density benefits, and then the higher grade quality of heat. You've got a higher delta T, or you've got the usable heat as well. So, I mean, yeah.
Okay, last true question is how will collaboration transform the energy and carbon intensity of data centers now and in the longer term? Because we all know progress and innovation and the partnerships. I always stress this because this is very much the key, is collaboration between large companies, small companies, government, education. If there's collaboration, it actually is better for innovation and it infuses growth faster and knowledge sharing. And so I would like to get your last final thoughts on that before we open for Q&A. Of course, a little bit later than we should, but
Okay,
it is.
I'll definitely start on that. For us at Nvidia, we see partnerships as absolutely key, and it's also changing the way we relate to users of GPUs. So in the case of Shell, they're everywhere as an energy infrastructure that has to be built. Shell is truly global, has a global reach and end to end from the beginning to the end. And it's the same with Microsoft. Microsoft is an enormous force in IT, a huge hyperscaler able to provide access to the processing and AI resources that are needed to run, I mean, so many things. You talked about smart cities, traffic, autonomous vehicles, just being smart buildings, all of these things will require infrastructure to manage all that. And the energy that underlies all that is something will have to be built in. And that is why we see these partnerships as extremely important for us and how we solve some of these problems as they go forward.
The collaboration and partnership with large corporations such as Nvidia, Shell, and many others is unbelievably important. One example that I can just highlight right now that kind of ties back into the question around PPAs is, you know, over the last 10 years, corporations pushing for renewable energy has driven down the cost of wind and solar by 90%. 90%. And that's just because of basic market economics. Market supply meets market demand. If we're looking for renewable energy, we're looking for renewable energy sources. And you've got more mature technology, you've got more companies that are pushing for it, and you've got mature manufacturing, so on and so forth. I mean, that's just one example that is just tremendous, though. We've driven down the cost collectively across many organizations 90% for renewables. So.
Yeah, I just say, Suki, that nobody can drive all of this change by themselves,
Exactly.
right? So it's about the partnerships that Guy talked about between us as corporations, but also with governments, with society. There's an element of having a common understanding, which is difficult enough, right? So creating a common language to say these are the challenges and we all have the same understanding, let's go forward and work together on it, is also incredibly important. And you don't get there without, well, just talking about it together, right? And getting there. And then secondly, I'd say that you got to showcase that it can work. So you do have to sit together, and it sounds, corny, but you got to sit together in a room and say, if we're going to do immersion cooling, right? How does that work for the chips? How does that work for the data center? What are the important things? How does that work for the liquids? Do you need single phase, dual phase? What's finally the best solution? And you got to test, and all of that is in an environment of trust. And you got to create that between us and then society and the government bodies in order to move it forward. So yeah, it's the most important thing. To your point.
Yeah, I would like to close on that because I think a lot of people, when we have discussions about technology, we do sometimes forget about society. We have these very high-level discussions where we're talking about a technology, but we forget about the average person who doesn't, one, understand what AI is, two, doesn't understand what the term tech is very broad. But then when you get into subjects like data centers and actual terms like immersion cooling, they don't understand what that actually means for them in their everyday life, in their house, how you're running a fan and the electricity. They don't understand that. So I think one of the things we have to do is really make the language a little bit more easy for the average person to understand, and also to remember to include them in the discussions that we have going forward. And I will open for questions because we're late on that, but I really wanted to get those final points in. So, questions? And I knew there would be many. Okay, mic person, let's start up front here on the left. And then we're going to go to this gentleman here and then this lady over here.
Hi, my name is Ala Lessa, and actually it's interesting to hear your perspective from the data center and technology, but as previously mentioned, and I think following on your last question, without energy, a lot of these concepts and technologies will not be viable. We're in an era with a massive shortage in energy globally, but more importantly, the development of new energy project infrastructure, and with energy transition being a bottleneck, there needs to be an integration. So my question is, how are you working with the energy sector specifically to build new power plants, and how do you finance them? But more importantly also, how do you see that in the transition itself from a traditional energy source of gas-fired power plants where you need a base load to stabilize the grid, and adding renewable energy. Renewable energy in the current grid would not be sustainable without base load. So how do you
Thank
address
you.
that question?
Thank you.
I guess I can start with that. So that's where innovation plays a key role. And something like long duration energy storage, for example, where you can then store the renewable energy. So you can use the renewable energy that's created from wind and solar off peak hours. So if the sun's not shining, obviously at night, you can store that energy. So really, I mean, fundamentally, you can transport energy in two different ways, right? Through space and through time. So through space, from one location to another via transmission, and through time in storage. Say you can use long duration energy storage, for example. So, I mean, that's my response to your question. So right now, that is something that we're actively pursuing. I actually sit on a board for long duration energy storage, along with a lot of different industry peers and colleagues to pursue innovations such as that. So we can look at decarbonizing the grid at a larger scale, at a system-wide scale. I'm not sure if that answered your question. It's an expensive solution for now. It is. But again, back to the wind and solar energy production, that was 90% more expensive 10 years ago than it is today. So collectively, collaboratively, with the right partnerships, with governments and companies, we hope to drive that down. I'm not saying that's the only solution. That's just an example of where innovation comes into play, and renewable storage. So.
All right, I'm cutting you off, Ryan.
Yeah.
'Cause
Am I
feel
allowed to like a 2-second?
Yes, you
still,
can do a
Suki?
2-second.
I also want to give credit to the tech industry for driving that change. Okay, not just Microsoft and Nvidia, but also lots of other companies really being at the forefront of saying we're going to need to make this change and we're willing to invest in it. And yes, some of it is more tomorrow, but a lot of it's already today as well. So it's the long duration batteries. There's also the usage of renewable diesel for backup. That's being looked into. There's and yes, you're right. I mean, the 24/7 or 100/100/0 or around the clock energy goal is hard to attain. In the meantime, though, if you are able to finance through long-term offtake agreements the build of new, let's say, offshore wind facilities, for instance, as an example, that will actually really help the grid. And then in order to get to that, 24/7, you're going to need those trading capabilities, and but those racks still get into the system there. So there's, there's a lot of credit that goes to this industry as well, I think, in pushing that forward.
Oh, go on. Oh my gosh. We're never going to get to these last two
Okay,
questions.
I could talk about that all day. though. So,
Me
so
too. Yeah.
Yeah, I know. They can talk about it should be a half day at least, minimum. I'm going to have this gentleman ask his question, and I really want to get to this lady over here. And I know there are other people that will want to put their hands up afterwards, but I'm cutting you off because that thing is flashing in about 40 seconds. So go ahead, ask it.
Yeah, I'll
Be
try and
succinct.
keep it short. Yeah, so thank you for the talk. My question was, in the same way that I guess in your businesses you have financial budgets for different parts of the business and P&L and structures and that kind of thing, have you explored or are considering carbon budgets or GHG for different parts of the business? So this is the amount of carbon you can emit in a particular kind of time period, or I guess, yeah, that kind of thing.
Who wants to do it?
It's a broad question. I can talk about it. So yes is, I guess, the answer. We definitely, you asked the question, have you considered it, and is it part of the discussion, and etc. Yes. You got to look at the abatement curve of every different sort of business and see, what's reasonable. But I mean, at Shell, I'd say we have, it's linked to top executive pay now as well, and we have our targets for scope 1 and 2 which are out there, right, for 2030 and we've got our 2050 net zero. So absolutely, you're not going to get there if you don't then make it real by putting targets on there. So yeah, that's in our case.
And I'm going to have this lady ask her question.
Sure. Ulrike Weissing, SVP Energy Transition at Valorec. Shores, and first of all, thank you for a great discussion. Shores, you mentioned biodiesel for backup generation, and one of the things you haven't really touched is backup generation and the fact that you use diesel today for that. What do you see in the future? Is it battery storage? Is it hydrogen? Is it biodiesel? Are you exploring all of it? What do you see?
We're exploring all of it right now. We've actually got a program right now. We're transitioning all of our diesel generators globally from petroleum-based diesel to renewable diesel. And we've already transitioned over 400 megawatts just this fiscal year alone. And in the next 2 years, we'll be 100% renewable diesel. And we are experimenting with a hybrid type solution set, like you just mentioned, with really there is not going to be one specific silver bullet. So you're going to have to look at hybrid solution sets, like you just mentioned, renewable diesel, hydrogen, natural gas, battery energy storage solutions, long duration energy storage solutions. So yes, we're looking at all of those things right now.
Okay, all right. Yeah, we all see the red flashing zeros in front of us. But I do want to say thank you very much to my wonderful panelists, Shores, Ryan, Guy, and thank you very much to the audience for asking wonderful questions. I know there were more. I'm sorry. You can catch them in the hallway, ambush. And please give my panelists a wonderful round of applause. Thank you very much.